All right, so last section we talked about the product property, right? It was the product of powers property, but now we are talking about the quotient powers property. So remember, quotient is the answer to a division problem. So I'm not sure if you guys noticed, but we were all doing multiplication. We didn't do any division. That was on purpose. The rules are different for multiplication and division, right? Normally, not always, when you multiply, numbers tend to get bigger, right? Well, when you divide, numbers tend to get smaller. That's not always the case, right? Because when you have numbers less than 1, it kind of messes with things a little bit. But for the most part, that's true. So we have different rules now. So we have the quotient of the powers property. So what we're doing today, we're going to be using that property, right? We're just using the quotient of powers property. So I'm doing it a little bit different this time. If you notice, last section, hopefully you guys watched it, we went through a lot of the problems, and then I gave you the property, right? But instead, we're going to do it a little bit different. What we're going to do here, we are going to first, I'm going to do a little example on the side, and then we're going to get the rule really quick, and then we're going to use the rule. What if we had a to the fifth divided by a cubed? Then that would be a times a times a times a times a, right? Divided by a times a times a. Well, notice these a's cancel out, and we are left with two a's on top. So a to the fifth over a to the third equals a squared. So how did I get from 5 and 3 to 2? Here's the key, guys. 5 minus 3 equals 2. That will always be the case. Therefore, the rule is a to the m divided by a to the n is a to the m minus n. Write that down, screenshot this. Make sure you understand this, guys. Whenever you're dividing, you subtract the exponents. But remember, when you're multiplying, so this multiplying right here, you add. So be careful. Dividing, you subtract. Multiplying, you add. This section is mostly division, so we're going to be mostly subtracting. All right, let's go to the next slide and use those examples. So simplify the expression, right? So here, what we're going to do, 4 to the 6th divided by 4 to the 3rd, that's going to equal 4 to the 6 minus 3, which is just 4 to the 3rd power. Done. Crazy. Easy, right? This is going to give me, can I move that a little bit? Sorry. 5.1 to the 3 minus 2. Notice it's always the numerator minus the denominator, which just equals 5.1 to the 1st. So guys, you don't need that, so just 5.1. But if you want to put that, that's okay. Next one, this is going to be negative 3 to the 8 minus 3 power, right? Which is just negative 3 to the 5th power. And then this last one, whoa. Why do I do that? Interesting, right? So let's just do this separate. This one's going to be a little bit weird, a little bit more different, right? Let's do the numerator first. So right here, this 6 and the 1, that's the same as e to the 7th power. Do you guys agree with that? Right? If I multiply across, then I'm multiplying. For this second one, 4 and 2, that's the same as e to the 6th power, right? So therefore, I have e to the 7 over e to the 6th. Well, that equals e to the 7 minus 6, which just equals e to the 1st power. Hopefully you guys get that. I multiplied across first, so I use the product's power rule, and then I use the division one after and I subtracted. So I added the exponents on the top, I added the exponents on the bottom, and then I subtracted the total. Let's do a couple more examples. Whoa, looks really intense, right, guys? But it's not that bad because we just need to line up whatever the common bases are. So notice in A, you have a base of A and B in both, and then in B, you have A, B, and C. So let's just first combine them. So I'm going to look at these two A's. I'm going to look at these B's. So A to the 8 divided by A to the 4th, that's A to the 8 minus 4 times B to the 12 minus 6. So my answer is A to the 4th times B to the 6th. That's going to be my answer. For this next one, I'm lining up the A's right there. Look at the B's right there. And then C is on its own. There's only one C, so that value is not going to change. Therefore, we have A to the 5 minus 2 times B. Look, this is an imaginary 1, right? So B to the 3 minus 1 times C is only 1C, so C squared. So that's A. And remember, guys, this is a subtraction problem. I just didn't write that big. There you go. So that's A to the 3rd, B squared, C squared. That's your answer, guys. A to the 3rd, B squared, C squared. And remember, if you don't want to put this right there, you don't have to. You can just leave it like that. Just smush them together a little bit. All right. So let's just check, see how to do these. Whoa, 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 whoa. A lot of stuff going on there. So let's just go slow, take our time, one step at a time, and I guarantee you we'll get our answer. So the first thing we need to do, parentheses, right? So here, let me bulk this up a little bit. Right there. We need to do that inside part first. So A to the 5th squared, that's going to give me A to the 10th, right? But it's still squared over A to the 5th. So therefore, when we do A to the 10th squared, we get A to the 20th over A to the 5th, right? So first I did the top, and then I squared it, right? So A to the 5th squared is A to the 10th, but I need to square that also because these twos match up right here. Those twos match up, right? So therefore, I just moved it down. So I got A to the 20th divided by A to the 5th, and that's going to equal A, not A to the 4th. Remember, whenever you have the same base, the exponents we're dividing, you subtract. So A to the 15th. All right, next one. We can't do anything yet until we fix this bottom. That's sloppy, right? You're taking an exponent to other exponents, so we need to do that first because we need to do those parentheses first. So what we're going to do, I'm going to rewrite x to the 10th, y to the 10th, z cubed, same as the numerator, but then I'm going to square this. So that's x to the 5th, y squared, squared. So that 2 goes to both. So therefore, that leaves me x to the 10th, y to the 4th, and that's it, right? Make sure it goes to both of them, not just one of them, both. Now, guys, notice x to the 10th and x to the 10th cancel out. So therefore, we are left with the 10 and the 4 right here. So the 10 and the 4 right there. And then this one by itself is just the 3. So what we're going to do, we have y to the 10 minus 4, z cubed, which is just y to the 6th, z cubed. And that's going to be your answer, guys. Y to the 6th, z cubed. The x is canceled out. The y z subtracted, 10 minus 4 is 6, and z cubed stayed the same. Yeah. All right, your homework due on Friday, 16.3, 4 through 28 evens. So one extra problem from the other lessons. That's all right. It's not too bad. One extra problem. All right, challengers, good luck on this. Sure you guys are fine. If you have any questions, just let me know. I'm happy to answer any questions that you guys have. Have a great rest of your day, challengers.